Matriculants. Now let's come to a galvanic cell. It's a short topic, ne? So brief nje ngikunike phaya ipicture yokuba kwenzeka ntoni. Then must understand the questions quick. I won't waste much of your time. I just want to give you a clear picture. Okay. A galvanic cell in electrodes as E2. I believe you already know a cell yakuba indon. So I'm not here to explain the meaning of a cell or a definition of a cell. I'm just going straight away to a galvanic cell. A galvanic cell in an anode and cathode. Nento zimbini. Njengoba nento zimbini nje, this one is negative. This one is positive. Lay negative loses electrons. This one. Electrons. This one gain electrons. So njengoba nento zimbini, why it loses electrons le? It loses mass. It loses mass. Then it gains mass. So njengoba gain mass apha, we use the terminology ethi oxidized, reduced. So makusithiwa into ya oxidized kuthiwa it lose mass lona. Makusithiwa iya reduce is reduced. Ithetha ukuthi it gain mass. So please mind those terms, ne? So apha kwenzeka oxidation. Kwenzeka oxidation here. Half reaction. Apha kwenzeka reduction, half what? Reaction. This is what is happening. In this side, oxidation number increases here. Oxidation number increases. Upper oxidation number is what? Is reduced here. So this is actually what is happening. We call this one that is reduced. They oxidized. Sibiza ngandonle reducing agent. A reducing agent is oxidized. So it will appear the anode. Then oxidizing agent is reduced. Is appear sharp with cathode. So it land in galvanic cell. I've got two half cells here. There's electrodes the join low voltage. This reaction is spontaneous. So this is negative, this is positive, there is my salt bridge. You see, this is what I have. We got the book solution up. So this solution is metal, sulfate mostly, or nitrate, it will depend. Also this side, it will be metal. The metal will use sulfate. So here we are using sulfate as what? The sulfate as a solution as salt. So what happened here during a reaction? So the reaction upper, neg anode, ya breaker, ya kripuk, of course. So it break, it loses mass, then those ions, ziyapi, ziyaku solution. So ions zayo, zizawahla zibelapha. But the electron will be left p electrode yakho will be left here electrode le. So as electrons will be transferred to this side. So when this metal receives electrons, because here you've got metal sulfate, so there are ions of this metal in the solution. And these ions are what? Are positive. So they will be attracted to this electrode. So this electrode will act as a magnet. Kala electron ifika kula electrode, izofika act as a magnet, then as ions lapha will be attracted pha sijikeleze la electrode zihlale pha. And so once ngantoni ngoku, these ones leave the solutions, zinyuke ziyohlala pha. Xa sezihleli pha ezi ziyangena kwi-solution. Kulapho ibhetri yakho ngokufumana sibisebenza khona. If une-battery yefowuni iluza iyayiphela, if une-battery yeradio iyayiphela. You see, it's because as ions ziyayishiya i-solution, and this solution now concentration yayo becomes very weak. Then now xa seziphelile as electrons, this cell bridge now will provide negative, it will provide positive ions ngapha, negative ngapha, to maintain a neutrality. That is what is happening with galvanic cell. So le iluzayo sithe kwenzeka ntoni kuyo? Oxidation. I-oxidation half reaction. There is a loss of electron. We always write it as a metal which gives out electrons. I will use 1A now. This is just an alphabet which represents any metal, and this one will be in aqueous solution. Now, you see, so oxidation half reaction which occur where? At the anode, because oxidation yenzeka up. So lena ikhipha electrons to that side. I-reduction half reaction yona kwenzekani kuyo? Yona le electron inguphi? Plus, it's in the solution. There's ions kwi-solution ezifumana electron, then zireduceke zibe yintoni? Zibe yi-metal, which is B, or a solid, aqueous up. They believe kakhulu ku-practical. I don't believe in theory, because theory I don't see, but the practical work is what I see. So if they tell me that oxidizing agent is reduced, reducing agent, yes, oxidizing agent is reduced, oxidizing agent is reduced, reducing agent is oxidized. Yay, oxidizing agent, if now in land. Okay, let's first write inert reaction up. So inert reaction yako here will be AS plus B plus aqueous into A plus aqueous plus B as solid. So when you look at this reaction, this is a net redox reaction. So when you look at this, A is solid from 0 to 1. So apa siyabona from this reaction kin A oxidation, because once again oxidation number kaloku increases. So we have 0 apa, and now we are having 1 there. So oxidation number yakho sithe increase kwi-oxidation. So yenzeka anode. Kwi-anode kwenzeka oxidation half reaction. Oxidation half reaction increase oxidation number. Reduction half reaction, oxidation number decrease ion. So njengoba decrease oxidation number, uphi wakho uqala eyintoni engu-plus, then abe metal. This is what I love. They can say right is cell notation. Cell notation is the same thing as this one, but here we include electrode Z. So this electrode to burn to A plus aqueous solution, salt bridge, B plus aqueous solution, salt bridge, electrode, which is PS. So even from this one, you can see that reaction. So what you must know when we move from cell notation to this reaction. So in the we extract the anode in a cathode from this. Extract the anode and the cathode from this. So from this reaction, you can see the anode yako nans ku A pa. i-cathode yakho kuphi. So nansi into esinoyifumana pha. So ithi le nto ngoku kwezi reaction uzenzileyo lo A u-oxidizwayo yi-reducing agent. Sithe mos i-reducing agent is oxidized. So i-reducing agent yile i-lose electron. So kule reaction this is what? This is what? This is reducing agent. This is reducing agent. Then this one, because iqala ku-ion, you see, this is oxidizing agent. Sometimes they may give you a reaction, you don't oxidizing agent, you don't reducing agent, especially with multiple choice question. Sometimes but A reducing agent, choose the answer correct. So you must know what is happening. So this one, lose electrons. Reducing agent, gain electrons, oxidizing agent. So that is it for a galvanic cell. Now let's look at just a quick example. Here, une table phaya ekufuna ukuyisebenzisa back kwi-table yakho abayisebenzisayo. That table ndiyayithanda, but I always use the one enabantu pha phezulu not le Fe, le lithium phezulu. I always use le lithium phezulu nale in a base yakho ezantsi. So I always use those ones. That one. So apa dina reaction yam engubani between this. I'm given this type of cell here. So this is my cell and its reactions zimbini. This is just EG example. So I've got this cell and I have cells here, this electrode and Y, got my Y here to that, and then my solid bridge, of course we know. Then from here I've got indole EAG what? AG nitrate. So they use the nitrate solution which is aqueous. So this is my AG, this electrode which is here. This is my AG, and this side I've got aluminium. So as in a center upper, if you look at the voltage according to the table in 7 side, most of the voltage lane loss in a voltage in nan, ilena in negandon, ile is oxidizer, lena voltage high, ile is happy, good reduction. For example, upper, if voltage is aluminium, ilengana ban kwa table. Na strong aluminium yako aluminium yako ilingana negative 1.66 volts. That is your aluminium. Sikhangele phaya u-AG wako ulingana bani yena? U-AG yena ulingana VAG ulingana 0.8 volts. So from these two you can see ndoba le negative ya oxidizer, so this is negative terminal, le I positive kwenzeka reduction kuyo, so that is positive. That's what is happening. So from those questions you can go, what can we do now from that information? You can see ndoba if voltage go Y here is the difference between the two, which is E cell. I believe you know how to calculate E cell work, which is E cathode minus E anode, which is E cathode yakho ngibani ilena mos 0.8 minus, don't forget to pull a minus. Yay, ungayenzi lona. Kwa calculator yakho you will get the answer by yourself. Uze ne solution yakho. That is how you calculate indoni calculator the voltage of the cell. That is the reading which is cell yakho as a reader by operator paya. You see. Now from this, it in E oxidation half reaction here. izawudinga oxidation nansi mos. So yenzeka phi? I-aluminium. So i-aluminium yona iluza ii-electrons ezingaphi? Eziyi-3. Iluza ii-electrons eziyi-3 plus 3e. That is aluminium. So nje iluza ii-electrons eziyi-3 kwenzeka ntoni Ag? Ag yena ugain ii-electrons ngapha. So Ag plus ugain i-electron yena abe yintoni emva koko? Abe yi-metal. So now we must balance the equation. Kukho 1 apha, multiply this by 3 so that electrons zakho zizawulingana. So for this reaction you'll have 3a plus 3e, which gives you a wakho, which is 3a. So inet yakho ilingana bani? Inet yakho will be aluminium plus this one, Al plus 3a plus siyakhandishane zombini, Al3 plus bani? Plus Ag. Sorry, this is Ag. That's about A. This is Ag. So that's what is happening here. Because in the way is silver. So that is how you write i-cell notation yakho. Zizobuzwa kwezi questions madoda. So ufuna ukwazi izinto ukuziphendula, uzenze ngendlela efanelekileyo. Uthathe imarks zakho pha. Uhlukane nento abantu abazifunayo. Pass uhambe e-university next year. Akho nabuzazi. You see. So now you know how to calculate i-cell yakho. You know how to calculate i-voltage yakho. You know how to identify anode and cathode. That's what is important, you see, because sometimes they may give you a reaction, you see, already. So you must know how to move from a reaction to a. For example, if bagniga besithi izinc yakho ikala solid, then zinc aqueous ena 2 plus. So says it. Then ibe copper 2 plus. They have a common reaction. Then we see you see. So from this you can see zinc yakho oxidation number yayo increase. Copper yakho oxidation number yayo iyehlukene. And we know copper is reduced. Reduction half reaction there. Zinc yakho is oxidized. So the number of oxidation number is increasing. So zinc yakho up will have oxidation number a high. So apha ithi lento yi-anode zinc yakho, i-cathode intoni? I-copper. So zizinto ezi efuna ukuzazile, akho nto nabuzazi. Then you take your marks. Then I will hear from you if you have questions onazo, because I just show you a principle. So quick questions odibana nazo, especially kuzobhalishayana. I expect only questions so that we can answer those questions. So as bayibona principle uzafikelela kuthi ke ngalo information selonayo. God bless you.